Good evening and welcome back to the new session. This is a problem from Pure Math 3, May-June 2018. Solve the equation cot theta plus 45, which is equal to 2. So let us see how we could solve this problem. And the given domain is between 0 to 180, where 0 and 180 are not included. Cot theta can be written as 1 over tan theta plus cot theta plus 45 can be written as 1 over tan theta plus 45, which is equal to 2. I write the first fraction as it is, 1 over tan theta, and this in the denominator can be expanded using tan a plus b. So tan a plus b is tan a plus tan b divided by 1 minus tan a times tan b. So therefore 1 over tan of a plus b could be written as just the reciprocal of this right hand side. So we have 1 minus tan a tan b divided by tan a plus tan b. So I just write this 1 over tan plus theta plus 45, 1 over tan of theta plus 45, where a is theta and b is 45. So just replace a and b here. So which is 1 minus tan theta times tan 45 divided by tan a plus tan b, which is tan theta plus tan 45, which is equal to 2. On the left hand side, we have 1 over tan theta plus tan 45 is equal to 1. So therefore, tan theta times 1 becomes just stays as tan theta on the numerator. So we have 1 minus tan theta divided by, this is also 1. So you have tan theta plus 1, which is equal to 2. Now to simplify the equation, like just to show the equation in simplest terms, like a normal equation, I just try to replace tan theta to be y. So therefore this equation becomes 1 over y plus 1 minus y divided by 1 plus y is equal to 2. I just find the least common multiple of the denominators. So I have the product of y and 1 plus y as it is. So when you compare each denominator with the LCM, this denominator has to be, the first denominator y should be multiplied with 1 plus y. So therefore, the numerator 1 should be multiplied with 1 plus y. So 1 times 1 plus y plus. If you compare the second denominator with the least common multiple, this 1 plus y should be multiplied with y. So therefore, the numerator also should be multiplied by y. So you have y times 1 minus y, which is equal to 2. So now we have a fraction which says 1 times 1 plus y times 1 minus y divided by y times 1 plus y, which is equal to 2. Let us just expand the brackets here. You have 1 times 1 plus y will give us just 1 plus y as it is, and y times 1 minus y will give us y minus y square divided by the denominator y times y 1 plus y will stay as it is, which is equal to 2. Here is the equation. All right. Now we just simplify the numerator. Y plus y is 2y. So 1 plus 2y minus y square divided by, I just open the brackets here. Y plus y square is equal to 2. And I just, since you have common denominators on either side, you could just cross multiply. So this 1 goes to the left hand side as a product. Y plus y square goes to the right hand side as a product. So therefore you have left hand side multiplied by 1 is 1 plus 2y minus y square, and right hand side is multiplied by y plus y square becomes 2y plus 2y square, just a cross product. I hope you know that the cross product could be done only you have a single denominator on the left hand side and a single denominator on the right hand side. So now I could just cross 2y and 2y on the left hand side and right hand side becomes 0, and just move this negative y square to the right hand side becomes positive y square. Already we have 2y square existing on the right hand side, so it becomes 2y square plus y square, which gives us 3y square. which is equal to 1 on the left hand side. So therefore, y square is equal to 1 over 3. And we know that solving an equation, the equation from y squared to y, just to find the square root on both sides, the right hand side will have two values, which is positive and negative. So we have y is equal to positive negative 1 over square root of 3. So now I could just replace y back to tan theta. So tan theta is equal to positive negative 1 over square root of 3. And I will take this as two different equations. One is tan theta is equal to positive 1 over square root of 3. The next one is tan theta is equal to negative 1 over square root of 3. I hope you guys followed me so far. Let's see the final process of solving this equation. Once we have tan theta is equal to 1 over square root of 3, theta is equal to tan inverse of 1 over square root of 3, or arc tan of 1 over square root of 3, which will give us 30 degrees. Now this 30 degrees is basically called the reference angle. What is a reference angle? A reference angle is an angle between the OP and the nearest x-axis. So OP, usually when we choose a point on the circumference, we always call it to be P, and we just connect it with the origin center, which is OP. So this is what I'm trying to say here. The reference angle, I've just shaded here. This is your reference angle. It's always an acute angle. It could be either just directly theta in the first quadrant. When it comes to the second quadrant, it is 180 minus theta. When it comes to the third quadrant, it is 180 plus theta. And when it comes to the fourth quadrant, it is 360 minus theta. It is always close to the x-axis, positive x-axis and negative x-axis, and depends upon which quadrant it falls, right? So in this case, I have two different equations. One is tan theta is equal to 1 over square root of 3. Tan theta is positive, all positive in the first quadrant. Only sine is positive in the second quadrant. Tan is positive in the third quadrant, and cos is positive in the fourth quadrant. So tan is positive in the first and the third quadrant. So I just drew OP at the first quadrant and the third quadrant. And if you start, always we start the angle starting from the initial x-axis, goes on until the first OP in this counterclockwise direction. So right, so if I start from here, the initial x-axis, and go on until the first OP, I have 30 degrees. So that is one value which is equal to exactly whatever you have in this place. We have theta, so which is equal to theta. Next, I do the same thing starting from the initial x-axis, go on until the next OP, which is 180 plus 30, which is 210. So I have two values now, 30 and 210. The next equation is tan theta is equal to negative 1 over square root of 3. Here is that to find the reference angle, always try to avoid the negative sign. Sometimes you might get an obtuse angle. We are looking for an acute angle, so just try to ignore this negative sign and just find the tan inverse of, or sine inverse of, or cos inverse of just the absolute value which is on the right hand side. So here I don't consider negative sign. I just do the tan inverse of 1 over square root of 3, which is same as theta, which will give us 30 degrees. This negative sign will tell us in which quadrant tan is negative. So this helps us to draw OP. So therefore, tan is negative in the second quadrant and the third quadrant. So I drew OP here, the second and third quadrant. So how do we calculate OP usually? How do we measure OP starting from the initial x-axis, go on until the first OP, which will give me 150. Because we know this reference angle here is 30 degrees, which will give us 150, which is my first value. And the next one is, it goes on until here, the next OP, which is 360 minus 30, which will give us 330, right? So now we have four values. I hope you understood. We have four values. We had two different equations and we have four values now: 30, 210, 150, and 330. And if you listen to the problem, what the problem says is the domain is between 0 to 180 degrees. So you cannot consider some values of theta which goes beyond this limit, including 0 and 180. You cannot include 0, you cannot include 180. It should be between 0 to 180. If you see, 210 goes beyond the limit and 330 goes beyond the limit. So we just have only two values to be considered in this case, which is 30 and 150. So therefore, the final solution here, the final values of theta would be just 30 and 150. So thank you for watching, guys. I hope you understood, and I will see you all in my next video. Meantime, please like, share, subscribe, comment if you have any questions to ask. Thank you once again.